Greetings and welcome to the introductory video of Cet.SteelConnDesign. In our previous video, we covered the process of downloading and installing Cet.SteelConnDesign. Today, we will delve further into its features and functionalities. Cet.SteelConnDesign is a cutting-edge steel connection design software that is built on the AISC 13/14/15 standards. The software's design engine is powered by modern mathematical theories, offering users a powerful design solution. In the future, the software will incorporate seismic and other country-specific design codes to enhance its capabilities. Once the installation process is complete, the user can easily launch Cet.SteelConnDesign as a standard standalone program by clicking the shortcut. However, it's worth noting that the user won't initially see any 3D model or 2D drawing. To address this, we will be using FreeCAD for creating 3D models in this demonstration. It's important to keep in mind that Cet.SteelConnDesign shares the same user interface with both FreeCAD and Tekla, so the majority of the content covered today will be equally applicable to Tekla users. We can now begin the steel connection design process by selecting the SteelConnDesign workbench within FreeCAD. Once it loads up, you will see that there are three distinct windows displayed in FreeCAD. The window on the left is designated for members, while the one in the middle is designated for members and 3D connections. Finally, the window on the right serves as the combo control view. Within the combo control view, you will find a tab labeled Cet.SteelConnDesign, which consists of two distinct tabs, Projects and Connection Design. As Cet.SteelConnDesign is a project-based software, it enables the user to design multiple connections in one project. In these general settings, you can select AISC 13, 14, or 15 design codes, steel shape databases, and design method such as ASD or LRFD. You can also enter information such as company name, designer, email, or others. Of course, you can save or load these settings. On the right-hand side of the interface, you'll find the Model Management section. The Model Provider feature enables you to scan and import member or connection information from external software to your project. Currently, our software supports two model providers, FreeCAD and Tekla. We also have several built-in examples. This is an example of a two-story steel frame. We can load the project files from disk or save them. By clicking the Scan button, we can import the existing member or connection information from model providers. This is especially important for Tekla users. After loading the example, the beams and columns are added to their respective lists. Also, a beam-to-column connection labeled as B1_C1 is the connection list. Currently, we support two configurations, beam-to-column flange or web. From the beam list, select the top beam, B2. By clicking the Create Connection button, a new beam-to-column web connection, B2_C1, is created and added to the connection list. There are two connections in the connection list and B2_C1 is selected. To start the design, we click the Design Connection button. Upon completion, the system will return a pass or fail status. Clicking the Fit button displays the 3D members and connections in the second window. You can zoom or rotate the view. If we modify the shear load from 40 kips to 20 kips, the system will generate a revised connection design with shorter connections utilizing only 2 rows of bolts. Moreover, Cet.SteelConnDesign allows the user to undo or redo any changes made during the connection design process, providing greater control over the final design outcome. After designing, you may notice that some input fields are filled with a cyan color. This is a distinctive feature that indicates the values are generated by the system as design results, rather than user input. Our system permits leaving input fields empty. For instance, if the bolt diameter field is left blank, the system will automatically design a bolt diameter of 0.75 inches and display it in cyan color as a design result. If you undo the last operation, the bolt diameter will be reverted to 0.875 inches, and the system will use that value for design. Now let's talk about the design parts list, which is the most useful drop-down list in our system. Currently, we have 3 design parts available: beam, column, and web connections. When you select beam as the design part, you can change various parameters such as beam grade, section, sizes, loads, and others. If you select column, you can change the column grade, size, or rotation angle. For the web connection, let's go to the General tab. Here, you can make various changes. For instance, if you switch the vertical alignment from top to middle, the position of the 3D single plate will be adjusted after the design. If needed, the system's undo function can restore the previous plate location. Now we changed the hole type to a long slot hole and designed a slip critical connection. However, the design failed due to the given bolt diameter not being suitable. If we leave the bolt diameter input empty and allow the system to design the connection, it passes. And you will notice that the long slot holes have been created in the 3D model for the single plate. A multitude of parameters are available for adjustment within the connection design, with additional tutorials to follow that will provide comprehensive coverage of these details. After designing a connection successfully, the user can click on the Report button, which will display a design report in HTML format with properly formatted equations. This report can be printed in PDF format and saved for future reference. That concludes our discussion for today. We appreciate you taking the time to join us. Thank you.